Hello guys, in this video I'm gonna show you how to simulate a 7-segment display on LabVIEW. Okay, LabVIEW comes with any project in LabVIEW comes with two panels. The front panel in which you put your design, your control and output logic or output basically display or indicators, and this white panel here on the right is called the block diagram in which you make the connections and logic circuits. Okay, and you run your simulation in the front panel as well. So the front panel, like the front end, you don't see the details. All the details come in the block diagram panel. Okay. So I have already done the project. I'm gonna show you the output of this project, how we run it. So the 7 segment has 4 inputs. It takes 0, 0, 0, 0 until 1, 0, 0, 1, which is 9, from 0 to 9, because it shows numbers from 0 to 9, digits from 0 to 9. Okay, so we need 4 controls, 4 switches. Okay, each switch 1 or 0. So we have sort of switches uh, in LabVIEW. Okay, so this switch, if it's up, this means 1. If it's down like that, it means 0. So we're gonna start by 0. Okay, and see. We have also the LEDs that can act as like an indicator, on or off. Okay, so now all the switches are zeros, so we're gonna run. This is 0. You see, this is 0. Then for 1 in binary is 0, 0, 0, 1. If we turn, this is 1. 2 is 0, 0, 1, 0. We run, this is now digit 2. 3, 0, 0, 1, 1. Run. 3. 4 is 0, 1, 0. If you guys remember, 0, 0. If we run, this is 4. 5 is 0, 1, 0, 1. This is 5. 6 is 0, 1, 1, 0. And this is 6. 7 is 0, 1, 1, 1. This is digit 7. And not finally. 8 is 1, 0, 0, 0. This is 8. Finally, 9 is 1, 0, 0, 1. Run this. Okay. So let's see how to do that. I already have the project. So what I'm going to do, I'm going to create a new project to all the controls and the indicators, on the front panel. Do only one of the output, one of the logics in the block diagram panel. Okay. And be sure it's working as we expected. Then we continue here in this origin because it takes a long time, in the already made project, and show you how I did the other outputs as well, B, C, D until G. Okay, guys, so let's do that. So let's whenever you open like Logic Sim, sorry, LabVIEW, go to project, create project, do blank project. That's good. Finish. Okay, then here create in file, choose new VI. Okay, so this new VI will create these two panels for you. They come side by side, they come together. Okay, the front panel and the block diagram panel. Okay, so we said we're gonna do the controls together. So I'm sorry, we're gonna do the front panel together, which is the interface of the project. So we go to view and control palette, and from here we need a switch. So this is the switch in here. So we need 4 of these switches. Oh, we should choose one. Then you can Control C, Control V to create other instances, or you can just click as in and take whatever you like. We just need 4, so we're gonna delete this last one. Just click it and press delete. Okay. So you can choose the size and the font of these like instances. Just if you want to change all of them to the same size and the font, just choose all of them. Go here. So let's see. Size. Make it like 36. Okay. And then we can name them like A, B, C, and D. Okay. Now we need to change the size of the switch itself. That's so tiny. Okay, yes, yes. Okay. We just deal with what we have. Okay, that guy. And that guy. And that guy. Okay. Can it change the position? You should be able to do that. Yes. Press. Make all of them zeros for now. Okay. Now we need the indicators. So for the indicators, it's the same like panel here, square lid. Okay. And now we change the size of this square lid. Oh. We need another 4. And if you guys notice, whenever we create something here, some control or output, a copy of this one appears here. Okay. Remember, this is the front end, the front panel, the control panel, you can say, and this is what really happening. This is the design goes here. Okay. So we need another one. And let's name them A, B, C, D. Okay. So that's A. Make it in the middle here. That's B. Double click. Bring that guy here. C, D, E, F, and G. Again, let's change the size of the font. You can also Control B to make it like bold. If you want. Okay. That's basically, the contour. Now, nothing will happen if you, because there is no connection, you see, between the input and the output. Okay, so here are the 4 inputs. If you guys recall from our last video, we explained, the how to design basically a 7-segment decoder that takes 4 binary inputs and converts them to the logic that will make like the digit appear in the shape that we know. Okay, so I advise you to go back and check these videos, but we already have the solution. So I'm gonna depend on the solution directly to do the the solution. Okay, so we learned it from last time when we used logisim to solve this problem. Okay, that if you use logisim, you can have all the equations for the outputs here, A, B, C, D. So I'm gonna do one again here in this new project, and then go back to our old project, which is complete, and and just check with you the other ones because it takes a long time. Okay, for A is equal to B bar D bar plus C plus BD plus A. Maybe it's not clear, the font may be small, so we can also relate to another article on the web that contains solution. Let's just bring this up very quick in here. Yes, it's in here. So if you go up. So that's how I'm gonna share this link with you. I also shared last time. So this article contains the design of a 7-segment decoder. We just need A here. So here is A. Again, if this is not clear from Logisim, it should be clear from here. A, C, B, D, B bar, D bar. Okay? So let's see how to do that. So I'm gonna put that here on that side, and on the other side, we're gonna put what? We're gonna put this one here, the article. Okay, so what we need to do A or C or BD or B bar D bar. So we need first inverters because we need B bar D bar. Okay, so we need a way to input these logic gates. So if we go to our new project in here, okay. So this window here appears automatically for you. So I didn't open it, it was opened already. So from that, we can basically use or build a logic circuit. So we go to programming. There are many menus here. We go to the programming menu and we choose any logic gate we need. Look, there is an AND, there is OR, XOR, inverter, also multi-input AND or NAND. You can create from this one here, NAND, NOR, XNOR, or not XOR, and so on. Okay, so let's go back to the design. For that one, we need first inverters. So let's put that on the side here. We need inverters, so let's get the inverters. Here is the inverter. We need just 2 of them for B bar, D bar. So we need one in front of B. Okay, we connect them together. And we need another one, B bar, D bar. We need another one in front of D. So to connect, you see this dot here. It will appear when you hover over it. Once you hover over it, a link activation will happen. So you can basically create a link. Okay, so we have B bar, D bar now. So we need to AND B bar, D bar. So if we go back here, so we need an AND gate between B bar and D bar. So we need an AND gate. So let's get this AND gate here. Here is an AND gate. So this is D bar, and this is Mr. B bar. Okay. We need also BD. So we need another AND gate. Just click here, click on that block diagram window, and that function window will appear for you. So we need another AND gate to do BD. Go again to the cursor. BD. You can also control the line to make it more beautiful, as you see, or prettier. Okay, that's very good. Okay, so we have B bar, D bar, we have BD. Then we need A or C or BD, or we have B bar, D bar, we have BD, we have C, of course, and A. So we need now 1 OR gate, 2 OR gate, 3 OR gate. Okay, to do that, let's see. Or maybe more, let's see. Just again, click here, and we're gonna get some OR gates. The problem is that these OR gates can accept only 2 inputs. So we need more. Okay. So A or C. Let's do this. Let's do A or C first. Okay, second input. Okay. So A or C or BD. So another OR gate here. And then we take the output of BD. This is the one that gives BD this AND gate. So okay, so the output here is A or C or BD. Now we need another OR gate to connect all of that with B bar, D bar. This is the AND gate that give you A bar, B bar, D bar. So we need another OR gate here. This is another gate. So connect that to this one, that to this one, and finally to Mr. A in here. Okay, that's it, guys. You know, we have a circuit. Let's check if we have a problem. We can, by the way, run the simulation now. Of course, this will be off all the time. A will be on in certain times. Okay, like for number 2, A should be on. Okay, so let's see. So let's see if we can do something in here. Okay, so let's make them off. Just click on them. So let's see. We're gonna make for number 1, A should be off. Okay, B and C should be on, but of course there is no connection, so everything will be off. So let's check. Oh, this is, I'm sorry. This is 1 here is for 8. Okay, yeah, this is 1. Okay, so this is 1. Sorry, 0. This is the most significant bit. This is the least significant bit. Okay, for number 1, we need 0, 0, 0, 1. Okay, and as you see, let's check. Yes, it's off because for number 1, B and D should be on. Okay, for number 2, it should be on. A should be on. That's correct. Okay. For number 3 is like that. So A should be on. So let's do that. Should continue on. That's correct. For number 4 is like that. This should be on. This should be on. This should be on. This should be on. A should be off. Yes. For number 5 is like that. A, F, G, C, D. So A should be on. Number 5 is 0, 1, 0, 1. Yes. For number 6, it's A, F, G, C, D, E. So it should be on. Number 6 is 0, 1, 1, 0. Let's check. Yes, it's on. That's good. For number 7, it should be on because 7 is A, B, C. 7 is 0, 1, 1, 1. A is on. 8, all of them is on. So 8 is 1, 0, 0, 0. Yeah, that's correct. 9 is 1, 0, 0. It should be on because 9 is A, F, G, B, C, D. Okay. Yeah, that's so we did implement A correct. So you're gonna do the same, exactly the same for B, C, D until G. Okay, I have it already, so let's go back to our design. Okay, this is our the design that is already like completed. I did everything here for A, B, C, D until G. But we can do some like reduction a little bit for the circuit. Okay, so for example, A is equal to A plus C plus or BD plus or B bar D bar. BD plus B bar D bar. This is an XOR. Okay, so you don't have to do two AND gates and OR. You can directly do an XNOR. I'm sorry, XNOR, not XOR. XNOR or not XOR. Okay, that's why you're gonna see here XNOR here. Okay, for A. So let's compare. Let's go back to our the design that we just implemented here and compare. So look at A here, look at the circuit here and the circuit for A here. It's much simpler, right? Why it's simpler? Because I didn't do the PD, which is this one, or PD and the PD bar. These two AND gates and their OR become just one XNOR, which is this one gate. Okay, that to reduce a little bit the circuit. Okay. Also, you can do something like because all if we go like if we go here to the gates available, you have an AND gate, but it's only two inputs, restricted to input, two input or gate. Okay, so you cannot do that. If you have three inputs, you cannot use any of these, but you can do like multiple or multiple AND, like what we did. Okay. This is what we did in the project that we just created. So we did multiple OR gates because we are restricted by two input OR gates. So if we use this like compound arithmetic, okay, it can create for you a 3 or 4 or whatever, input or AND gate. So let's do one of these. Okay. So I have here an example. I hope I can see it. Yes. So here we are ORing the output of the XNOR. Let's go also for A. The output of the XNOR with the output of basically this is A or C, right? This is what we did. Okay. If this OR gate can accept the three input, we can take this output here and just connect it to this OR gate directly, right? So we're gonna save another OR gate. So let's do that. So I'm gonna do here, I'm gonna remove this one here. Okay, of course, once you remove something, you're gonna have a problem. Of course, it's an error, and this arrow will be broken, a broken arrow. That means you have a problem with your circuit or your design. So I'm gonna remove this old links or old wires. I'm sorry, this is a wire. Let's remove it. Okay, and I'm gonna use this guy here. It come again as two input. I can't zoom, but it can as two input and one output. So just to make like that, you can create whatever inputs you need. Okay, I'm just need 3, so I'm gonna go up. That's 4, 1. Yeah, that's now 3. We also don't need this OR gate. Now we're gonna connect the first link to that wire, second input to that wire, third input to the output of the XNOR gate. Okay, then the output will be connected to A. And you can make it more beautiful like that. Now, this guy is generic, can be and or. It's not or, by the way. It's not and also. It's generic. You have to choose. So to change its functionality from a change mode. So right click it change mode, and it's or by default. Okay, so that's good. So now we can run and see. So I'm gonna reset everything to check here and make everything 0. Run. This is 0, right? Of course, for 0, you should have all of them on except G, because this is digit. Okay, don't say they are zeros. It should be dim or off. No. Okay, for 1, uh, so far so good. For 2, so far so good. For 3, so far so good. For 4, so far so good. For 5, so far so good. For 6, so far so good. For 7, so far so good. For 8, so far so good. For 9, so far so good. So that's basically another way to basically reduce, the block diagrams that you have, because it's really ugly, especially for D. D is a very big expression. Let's review it. So for this is A, B, C, D. Look at D. Look how much gates you need. You need one AND gate here, one AND gate here, one AND gate here, and two AND gates here, because you are restricted with AND gates. It just accepts two inputs. So it can't accept B, C, the bar, D at the same time. So you have to have two AND gates, one to make B, C bar, and then the output of this one go to another AND gate that takes also D as input. The output of B, C bar, and another input is D. This will give you this term here. Okay. Then we need how many ORs? We need 1, 2, 3, 4 ORs. Okay, that's like very complex. Okay, but if you do with the trick with this like generic basically compound arithmetic box here, you can place as much as you want and reduce, adjust the inputs according to what you need. Then you choose basically by right click and change mode. You choose it's either and or. Okay, guys, thank you very much for watching. And this is basically the lab. Okay, so thank you very much for watching, and see you in another video. Bye bye.